All right, guys, this is Professor Roldan once more with College Algebra. This is going to be chapter 6.1 and 6.2 together because they both have to do with solving linear and non-linear systems. The difference would be that 6.1 would be two equations, okay, which this is more of like a review. And then 6.2 would be three equations. Okay, and this is the one that's going to be on the final. It's the new stuff. Okay. All right, so let's start with 6.1. We're going to go do the lesson for that before we do 6.2 or here on the side. So let's take a look at 6.1. 6.1, again, is just a review, and that's solving systems with two equations. Okay, so this is high school algebra, and we're going to start with number 2 of the lesson. Number 1 is sort of a little bit advanced, but it does have that video there for you to see. So we're going to start with number 2. Number 2 is pretty straightforward. So here we have two equations, and it says solve by substitution. Now, you can do it however you want to, but this is already set up for substitution. So, because y is by itself here, since y is by itself, it's already set up. This is perfect for a particular method called substitution. Substitution method. Okay? In other words, we take y is equal to 4x. So y is already by itself. We're going to take this and put it right there where that y is. And that's all substitution is. So put the 4x in here. And now I have an equation in terms of one variable. So now this can become 9x equals 27. And divide by 9, you're going to get 3. Okay? So this is not the answer. This is, we have to get the y coordinate because solving a system means that we're going to have two lines, in this case, two linear equations that intersect. So the intersection is an x and a y, okay? So we found the x, great. Let's go back and find the y. Well, we have an equation for the y, and it's y equals 4x. So we just put the 3 right in here, and we get 12, okay? Therefore, our point of intersection would be 3, 12. Okay? And if you wanted to solve this graphically, you would graph the two equations and use the intersection, go to second calc and then use the intersection feature for it to calculate this point for you. All right, let's do number 3 from this 6.1 lesson. And number 3 says to solve by the elimination method. And you will have slightly different, again, equations, but very, very similar. Okay, so as you can see, we can do elimination, but you could also do substitution if you wanted to. If you happen to like that method, you would just solve for x or y. X would probably be the best one to solve. So so you could use substitution by solving for x, actually the second x, but elimination may work out better. It's actually just preference here. So it asks you to do things a certain way. You don't have to do it that way. You can do it how you want. Okay, so by elimination, we want to eliminate one of the variables. So you want to choose the set of variables x or y that you can easily eliminate. Well, again, easily is another subjective word, but I prefer this scenario already there. Okay, opposite signs. I just need a 5 right here for that y term. So all I have to do is multiply everything by 5. So that's going to give us 30x minus 5y equals 5 times 2 is 10, 5 times 4 is 20, plus 1 is 210. Then we just transfer this right over. This one's not changing. And now we can combine both equations. So the 5y and the negative 5y, they both cancel. So that's going to leave us with 31x equals 248. And now we divide both sides by 31. And you get 8. Okay. So this is half of the coordinate of the intersection of the system. So we need to go find the y. And it doesn't really matter which one you put it in, whichever one's easier. I'd rather put it in the bottom equation, because the bottom equation, I don't have to multiply by 6 to make it 48. It's just going to stay 8. So we're going to put the 8 where the x is, and now we're going to solve for y. So subtract 8 from both sides, you get 30. And then divide both sides by 5, and you're going to get 6. Okay, so the final answer then would be 8, 6. All right, so number 2 is substitution. Number 3 is elimination. And then going back to number 1 of the lesson, it's a little bit more challenging elimination problem. So number 1 of 6.1 lesson is 2x plus 4y equals 14. And negative 3x minus 3y equals negative 9. Okay. So in this case, we want to, there's different ways to do this. I'm not going to mess with any of the terms. There's some GCS I can see there. But just leaving these two equations alone and only trying to eliminate and only focusing on that, we can make the x's. So I can make the x's look like a 6x. So I can say, hey, I can make these two look like 6x's, or I can make these two look like 12 y's. Okay. So I'm going to choose the 6x. I'm going to make the x terms look like 6x's by multiplying everything by 3 here and multiply everything by 2 here, and that'll give me positive 6 on top right here, and that'll give me negative 6 right here. So I know that the x's will eliminate once I get everything multiplied. So by multiplying everything by 3 in the top equation, I'm going to get 6x plus 12y equals 42. And then the bottom equation is going to be negative 6x, negative 6y equals negative 18. So the purpose of doing that is to combine both equations and eliminating the x. And then we're going to get 6y positive, and then we're going to subtract and get 24. So y equals 4. Okay, so now we take our 4 and we plug it in, and it doesn't really matter which one again because they're both going to be multiplied by something. So I'm just going to pick the top equation this time. So I can put the 4, right here. So 2x plus 16 equals 14. Subtract 16 from both sides. Get negative 2, and x is negative 1. So our final answer for the point of intersection of the system would be negative 1, 4. Okay, so that's a quick review of Algebra 1. Now let's do apply these methods to a nonlinear system in 6.1, and that'll be number 4. So let's do number 4. Okay, number 4, it's going to be similar but different. What's similar is that there are two equations, but what's different is that they're not linear anymore. Okay? So, you could do substitution, you could do elimination, or you can solve this graphically, but we want to use something. This is pretty much set up for elimination. And as you can see right here, all we got to do is put a negative 1 for this bottom term, and that's going to make those x squares eliminate. But that means if I'm going to do negative 1 for the first term, I need to multiply by negative 1 on the second term, making it positive. Multiply negative 1 on the last term over here on the right, and that's going to make it negative. So once I do that, those cancel, and that's going to give me, these are not like terms. So this time we don't have common terms. So y squared plus 3y equals 4. So this is different in the sense that we have a quadratic here. And then instead of, we're used to having linear equations. So we need to do, Then we want to factor quadratics. So this time we have positive 4 and minus 1. So now we have y equals negative 4 and positive 1. Now those are the two locations. We need the two values. We need the two locations for the x. So we need to go ahead and plug in negative 4 into the, I guess, top equation. Doesn't really matter. So x squared plus negative 4 squared equals 5. X squared plus 16 so when we subtract 16 from both sides, we're going to get negative 9. And that's going to create an imaginary number, the square root of a negative 1. So y equals 4 is not a solution. So then we try the 1. Put the 1 inside our equation. So that's going to give us x squared plus 1 equals 5. Then subtract 1, which will give us 4. So then x is going to equal negative 2 and positive 2. So those two x's will go with this y for this 1 for y. Okay, so the final answer then would be a negative 2, 1 and a positive 2, 1. Those are the two intersections of these two equations. Okay, so to look at these solutions graphically, let's go ahead and write down these equations once again. So the first equation is a circle. Well, yeah, it's a circle. And then the other equation is a quadratic. Or a parabola. So to graph, we need y equals, okay? So for the quadratic, we got to solve for y in each case. So we want to go ahead and move the x term over. And then divide by 3. So 1 minus x squared divided by negative 3. Okay, so you can type this into your y1, for example. And then the other one, we need to subtract the x squares. And then take the square root of both sides. And that's going to give us y equals plus or minus 5 minus x squared. So to graph a circle, you do need to do two equations. So this is, you can do y2 equals the positive version. And then y3 would be the negative version of this. So I'm going to go ahead and put this in my graphing calculator to see what we get. Okay, so these three equations are going to be put into a graphing calculator. And as you can see, we have the linear equation right here. The quadratic, which is the red equation, or red graph. And then top half of the circle is the positive version. The bottom half of the circle is the negative version, as you can see in blue and green. And then the intersection of the system would be negative 2, 1 and positive 2, 1. Okay, which confirms our answer. Okay, so the last thing you need to remember about in 6.1 with solutions of systems, all right, so you could have one or more intersections. Okay, like one solution, two solutions, like we see there. Okay. So this will be called consistent and independent. Or you may have only, they may never intersect. So that would be, so this one's like intersection or two intersections, for example. Or they may never intersect. So they may be like parallel, or they just may never cross. So like you got a parabola and a line like this. So both of those pictures describe non-intersecting. Okay, and non-intersecting is called inconsistent. And independent. Okay, and then the last category would be the same line. Okay, and that would be called so same graph, or overlapping. So this is going to create a consistent and dependent system. Okay, so just keep that in mind. All right, but everything we've been doing so far has been calculating those points right here. Okay, but on occasion you'll get non-intersecting, or you'll always get the same exact graph. Okay, so non-intersecting is no solution, okay, or the empty set, or null set. And then if they're always on top of each other, it's all real numbers. Okay. or infinitely many. Okay, that's it for 6.1. And we will see you in the next video. Actually, I forgot to tell you which one to focus on for final exam. You need to know all the concepts here, but the particular question on the final exam, the particular focus you need to look at would be this last one that we did right here, number 4. So the new question, or the new concept, is number 4 in the lesson of 6.1, and that's the one that's very similar to the one on the final exam. Okay, so just wanted to point that out, and now we'll see you in the next video.